आज हम करेंगे डिस्कस properties of colloids. So here we will discuss two important properties: Brownian movement or Brownian motion and Tyndall effect. Tyndall effect. So what is Brownian movement or Brownian motion? This Brownian motion or Brownian movement is the property of colloids. They show this property. This property was first of all discovered by Robert Brown in 1927. When colloidal particles were observed under ultramicroscope, they were seen to be in constant motion in a zigzag path in all possible directions. This zigzag motion of the colloidal particles is known as Brownian motion. This is Brownian motion. This is Brownian motion. This is zigzag path followed by colloidal particles. So this motion is known as Brownian motion. So what is the cause of this Brownian motion? The most probable cause of this Brownian motion is unequal bombardment of colloidal particles. Unequal bombardment of colloidal particles by the molecules of dispersion medium. Dispersion medium. So unequal bombardment of colloidal particles by the molecules of the dispersion medium. During this bombardment, the colloidal particles acquire. They acquire the same kinetic energy as possessed by the molecules of the dispersion medium. Owing to Lorentz size of colloidal particles, the acquired kinetic energy is manifested in the form of Brownian movement or Brownian motion. This Brownian movement or Brownian motion has a stirring effect. It has a stirring effect which does not permit the colloidal particles to settle and is thus responsible for the stability of the colloid. So that means Brownian motion adjusts the stability of the colloid, because this Brownian motion having stirring effect does not allow the colloidal particle to settle. So this was the property of the colloids, that is Brownian motion. This Brownian motion or Brownian movement is responsible for the stability of the colloid. Now, Tyndall effect. What is Tyndall effect? This Tyndall effect actually is observed when a strong convergent beam of light is passed through a colloidal dispersion placed in a dark place. The path of the beam of light becomes visible. Like this. If this is a colloidal dispersion placed in a dark place, a strong convergent beam is allowed to pass through this colloidal dispersion. The path of this beam becomes visible. It becomes visible. A visible banti. This effect was first of all studied by John Tyndall, a physicist, and is known after him as Tyndall effect. And the visible path is known as Tyndall cone. It is known as Tyndall cone. So what is the cause of this Tyndall effect? This Tyndall effect is due to the scattering of light by the colloidal particles. Actually यहाँ पर colloidal particles light को scatter करते हैं. Because of that scattering of light by the colloidal particles, so this Tyndall effect comes into existence. So the intensity is maximum. जो intensity of the scattered light जो होगी, intensity of the scattered light is maximum in a direction at right angles to the path of light. To the path of light. So path becomes visible when observed in that direction. इसका मतलब है जो light scatter करते हैं colloidal particles, the intensity of the scattered light is maximum in the right angles to the in the direction at right angles to the direction of the path of the light. If observed in that direction, the path of the light becomes visible. Path visual बनती है. एक और condition है, this Tyndall effect is observed only when the diameter of the colloidal particle is not much smaller than wavelength of the light used, and there must be great difference between the refractive indices of dispersive phase and dispersion medium. तब हम इस इफेक्ट को ऑब्जर्व कर सकते हैं. इस टेंडॉल इफेक्ट को हम ऑब्जर्व कर सकते हैं. Zygmundi in 1903. So Zygmundi in 1903 actually used the same effect and set up an instrument, set up a device, set up an apparatus known as ultra microscope. यानी अल्ट्रास्कोप बनाने जो इसी इफेक्ट पे काम करते हैं. जो जिगमोंडी है उसने उसी इफेक्ट को इस्तेमाल करके एक apparatus सेटअप कर दिया है, that is known as ultra microscope. This Tyndall effect helped to confirm the heterogeneous nature of the colloidal systems or colloids. So यानी जो colloidal system का heterogeneous nature है, so इससे confirm हो गया है इस Tyndall effect से. इसीलिए उसको help करते, Tyndall effect helped to confirm the heterogeneous nature of the this dispersional colloidal system or colloid. So this was about two important properties of colloids: Brownian movement or Brownian motion and Tyndall effect.